Welcome to our deep dive into the world of quantum computing. It's 2025, the International Year of Quantum Science and Technology. It's a pretty big deal. You know, marking 100 years of quantum mechanics, we've got a whole stack of articles and research papers. We've even got insights from companies like IBM and Sequantum, the companies leading the charge in this quantum revolution. So we're going to explore not just what quantum computing is, but what it means for all of us. From potential medical breakthroughs to the future of cybersecurity
Yeah.
and even investment opportunities.
What's so fascinating is that we're truly on the brink of a computing revolution, a complete paradigm shift, you could say. Quantum computers aren't just like faster versions of the computers we use today. They operate on entirely different principles, harnessing the mind-bending power of quantum mechanics, to tackle problems that would literally take classical computers millions of years to solve.
I think a lot of people hear the word quantum and their eyes just glaze over. So can we break down the basics for us? What are these qubits everyone keeps talking about? And why are they so revolutionary?
Okay, so imagine you're navigating a maze. A classical computer, like the one you're probably using right now, would have to explore each and every single path, one by one, until it finally finds the exit. But a quantum computer, thanks to this concept of superposition, can actually explore all possible paths simultaneously. And that's the incredible power of qubits. They can be both 0 and 1 at the same time, allowing for massive parallel processing.
Okay, so it's not just about speed. It's about tackling entirely new types of problems. Like I was reading that quantum computers could potentially crack the internet encryption we use today. You know, the kind that relies on the difficulty of factoring large prime numbers. Is that a realistic threat?
It's a very real concern. While the quantum computers we have today are still in their early stages of development, they're advancing at an incredibly fast pace. What would take a classical computer millennia to crack could potentially be done by a powerful enough quantum computer in a matter of hours. And that could render so much sensitive data vulnerable to hacking. It's a scary thought. And that's exactly why there's a growing focus on developing quantum-resistant encryption methods, things like quantum key distribution or QKD.
So it's almost like a race against time, developing quantum computers that can solve all these world-changing problems, but also making sure that we're prepared for the potential security risks that come with it. It feels like a bit of a quantum arms race is already underway.
Absolutely. The competition between the US and China in particular is really heating up. China's been pouring enormous resources into quantum research, exceeding any other country in terms of investment. And this has sparked concerns about national security and the potential for a technological gap. It really underscores the importance of not only advancing quantum technology, but also ensuring its responsible development and international collaboration.
So we've got this geopolitical tension simmering in the background, but amidst all of this, what excites you most about the potential of quantum computing?
Well, for me, it's the potential for groundbreaking discoveries, particularly in medicine and material science. Just imagine, quantum computers simulating complex molecular interactions at an unprecedented level, leading to faster drug discovery and the development of personalized medicine. Or think about designing entirely new materials with properties we haven't even imagined, like lighter and stronger materials for aerospace. Or more efficient solar cells for clean energy. The possibilities are truly vast.
It really does sound like quantum computing is going to touch nearly every aspect of our lives.
Yeah.
But it's still early days, right? How long until we actually start seeing real-world applications of this technology?
Well, companies like IBM are aiming for what they call quantum advantage by 2033, which is the point where quantum computers can definitively outperform classical computers for practical tasks. But we're already seeing glimpses of what's possible. For example, Sequantum is focusing on photonic quantum computing, which uses particles of light as qubits. And they're collaborating with global foundries to actually build a full-scale quantum computer. It's a fascinating approach because photonic qubits are less susceptible to environmental noise, which is a major challenge in building stable quantum computers.
So we've got IBM going for brute force with superconducting qubits
Yeah.
and Sequantum betting on the elegance of photons. It's almost like two different philosophies clashing. What about Google and Microsoft? Where do they fit into all of this?
They're major players as well. A couple of years ago, Google achieved a pretty significant milestone. They demonstrated quantum supremacy for a specific calculation. And Microsoft is taking a different approach. They're focusing on topological quantum computing, which is theoretically more stable than other methods, so it's a very diverse and competitive landscape. But surprisingly, one that's also quite collaborative, companies are realizing that a robust quantum ecosystem actually requires working together and sharing knowledge.
Okay, so we've got these tech giants battling it out. the potential for world-changing discoveries, and this looming threat to cybersecurity. It's a lot to unpack. But what does all this mean for investors? Where are the opportunities in this burgeoning quantum landscape?
That's where it gets really interesting. It's not just about investing in the quantum computing companies themselves. It's about recognizing the ripple effects that this technology will have across numerous industries.
So it's about looking beyond the hype and identifying the companies that will be transformed by quantum advancements, the ones that are strategically positioning themselves to leverage this technology.
Exactly. And that's precisely where a fund like Venture Sciences Strata Fund comes in. They're specifically targeting hypergrowth industries that stand to benefit from quantum computing, from healthcare and material science to finance and logistics.
Hold on. Let's dive deeper into the Strata Fund after a quick break. We'll be right back to unpack how investors can potentially capitalize on this quantum revolution.
Sounds good. We'll be right back.
We were just talking about Venture Sciences Strata Fund before the break and how they're looking to capitalize on the quantum revolution. For someone like me who's not exactly a Wall Street wizard, can you break down what makes this fund so unique and why it's attracting so much interest from investors?
Well, it's all about their forward-thinking approach, you see. They're not just blindly investing in companies building quantum computers themselves. They're looking at the much bigger picture. They're trying to identify those companies across various industries, like healthcare, material science, finance, even logistics. Companies that are truly poised to leverage quantum computing to gain a significant competitive advantage.
So they're betting on the companies that will actually be the users of this technology, the ones who will harness its power to disrupt their industries.
Precisely. It's a smart strategy, especially considering that quantum computing is still in its early stages. By investing in companies that are ready to apply this technology now, the Strata Fund is essentially getting a head start on what's likely to be a massive wave of innovation.
Can you give us some concrete examples? Like what kind of companies are we talking about here?
Okay, sure. So let's take the healthcare industry, for example. Imagine a pharmaceutical company that's utilizing quantum simulations to accelerate drug discovery. They could potentially cut development costs significantly and bring life-saving treatments to market much faster. Or picture a medical imaging company that's leveraging quantum sensors to develop incredibly precise and non-invasive diagnostic tools. These are the types of companies that are really attracting the attention of the Strata Fund.
Okay, that definitely makes sense. But there are risks, right? I mean, investing in any technology that's still developing always comes with uncertainties.
Oh, of course. There are always risks involved, especially in a field as complex and rapidly evolving as quantum computing. But the Strata Fund is trying to mitigate these risks by focusing on companies that have a strong track record of innovation, a solid management team, and a very clear vision for how they'll integrate quantum computing into their operations.
So it's all about picking the winners in this quantum race. The companies that are not just riding the hype, but are actually building something tangible and potentially game-changing.
Exactly. And that brings us back to our broader discussion about the impact of quantum computing on various industries. We talked about healthcare, but the potential really extends far beyond that.
I'm particularly intrigued by the potential impact on material science. I was reading that quantum computers could help design entirely new materials with properties that we haven't even imagined yet.
That's right. It's a field that's absolutely ripe for disruption. Imagine a world where we have materials that are both lighter and stronger than anything we have today. It would revolutionize industries like aerospace, construction, and transportation. Or think about the development of new catalysts. That could make chemical processes so much more efficient and environmentally friendly. Quantum computing truly has the potential to unlock a whole new era of material science.
And what about the energy sector? Could quantum computing play a role in tackling climate change?
Absolutely. Quantum computers are already being used to enhance the accuracy of climate models, giving us a better understanding of complex environmental processes. They could also help us design much more efficient solar cells, develop new methods for carbon capture and storage, and even lead to breakthroughs in nuclear fusion, which is a potentially clean and limitless source of energy.
Wow. It really does sound like quantum computing is going to touch every single aspect of our lives, from the medicines we take to the energy we use, and even the materials that make up our world. It's a lot to grasp, and I can imagine it being pretty overwhelming for some people.
It can be, but I think it's important to approach this with a sense of curiosity and wonder. We're witnessing a true technological revolution that has the potential to solve some of humanity's greatest challenges. It's an incredibly exciting time to be alive, and I believe we're only just scratching the surface of what's possible with quantum computing.
We were discussing cybersecurity earlier, and I wanted to circle back to that. You mentioned quantum key distribution as a potential solution to the threat that quantum computers pose to current encryption methods. Can you maybe delve a little deeper into how that actually works?
Sure. So quantum key distribution, or QKD as it's called, leverages the principles of quantum mechanics to create encryption keys that are, theoretically at least, unhackable. It relies on the fact that measuring a quantum system inevitably disturbs it. So if an eavesdropper tries to intercept the key, the sender and receiver will know about it immediately.
So it's almost like a built-in alarm system for your data.
Exactly. And it's not just theoretical either. We're already seeing some real-world applications of QKD. For instance, HSBC, one of the world's largest banks, is partnering with BT to test QKD technology for securing financial data transmission.
That's really encouraging. It seems like we're not just sitting ducks, waiting for the quantum apocalypse to hit.
No, definitely not. There's a lot of research and development going on right now to make sure we stay ahead of the curve when it comes to cybersecurity in a post-quantum world. And it's not just about protecting our data, it's about ensuring that the benefits of quantum computing are actually used for good and not for malicious purposes.
It feels like we're at a crossroads where the choices we make today will really shape the future of this technology and its impact on society. It's a lot of responsibility.
It is, but it's also an incredible opportunity. We have this chance to harness this incredibly powerful technology to actually create a better future for everyone. And that's what makes this field so compelling and inspiring to me.
You know, while we're on the topic of responsibility, I wanted to bring up the quantum arms race again. We talked about the competition between the U.S. and China. But what about other countries? Are they just spectators in this global race for quantum supremacy?
Not at all. Many other countries are making significant investments in quantum research and development. For instance, the European Union has launched its own Quantum Flagship Initiative, which is a billion-euro project aimed at accelerating quantum technologies.
So it's not just a two-horse race then?
Definitely not. Countries like Canada, Japan, Australia, and Singapore are also making their mark in the quantum world. Singapore, for example, is investing heavily in building a global network for quantum key distribution.
Wow. It's almost like a global awakening, with nations all around the world recognizing the transformative potential of quantum computing and vying for a seat at the table.
You're absolutely right. And while competition is inevitable, there's also a growing recognition that collaboration is crucial for really advancing this field. The challenges are incredibly complex, and the potential benefits are far too vast to be restricted by national borders.
So it's a balancing act then, between competition and collaboration, national interests and global aspirations. It's a fascinating dynamic.
It certainly is. And it underscores the importance of open communication, shared knowledge, and ethical considerations in guiding the development and deployment of these quantum technologies. We need to make sure that this revolution benefits all of humanity, not just a select few.
I think that's well said. It's a reminder that technology, even as revolutionary as quantum computing is ultimately a tool. And the way we use that tool will determine whether it leads to a brighter future or a dystopian nightmare.
You know, it's remarkable how much ground we've covered in this deep dive already. From the fundamental principles of quantum computing to the global race for supremacy and the far-reaching implications across all these diverse sectors.
It's been quite the journey. You know, we've explored the potential for groundbreaking discoveries in medicine and material science. We've grappled with the challenges of encryption in a post-quantum world. And we've even ventured into the uncharted waters of quantum finance. I think what strikes me most is the sense of urgency, the realization that we're truly on the cusp of something monumental. The decisions we make today will shape the quantum landscape for decades to come.
Yeah, it really has been a deep dive.
It feels like we're just scratching the surface, though.
Exactly. And I think through all these discussions, one thing's become abundantly clear.
What's that?
Quantum computing isn't just a technological marvel. It's a catalyst for profound societal transformation. It's really forcing us to re-examine our assumptions, our priorities, even our very understanding of what's possible.
I think what resonates with me most is that sense of possibility, but also the responsibility that comes with it.
Absolutely. As we navigate this uncharted territory, we need to be mindful of both the incredible opportunities and the potential risks. The potential for quantum computing to truly improve lives is undeniable, but we have to guard against its misuse and ensure that its benefits are shared equitably.
It's like this really delicate balancing act.
It is. It's a call for responsible innovation, you could say. A reminder that technological progress should always be guided by ethical considerations and a commitment to the greater good.
Which brings us back to the International Year of Quantum Science and Technology, right?
Precisely. It's not just a celebration of scientific achievement. It's an invitation to engage in a global dialogue about the future we want to create with this powerful technology.
It's about making sure that this quantum revolution benefits all of humanity, not just a select few.
You know, at the opening ceremony for the International Year of Quantum, Professor John Doyle, president of the American Physical Society, said something that really stuck with me.
Was that?
He spoke about the importance of honesty, recognizing both the remarkable triumphs and the inherent uncertainties of quantum science.
I think that's a crucial point. We really need to avoid hype and inflated expectations, while still acknowledging the very real potential of this technology.
Exactly. Quantum computing is not a magic bullet. It's not going to solve all our problems overnight. It's a complex and evolving field with many challenges yet to be overcome.
But amidst those challenges, there's that spark of something truly transformative, right?
Right. The possibility of unlocking solutions to problems that have plagued humanity for centuries.
It's exciting and a little bit daunting at the same time.
I agree. It's both exhilarating and humbling to be alive in this era of quantum discovery. We're witnessing a scientific revolution that will undoubtedly reshape our world in ways we can only begin to imagine.
So as we wrap up this deep dive, what are you most curious about? What questions are you still pondering?
You know, for me, it's about the long-term societal impact. How will quantum computing actually change the way we live, the way we work, and the way we interact with each other? Will it exacerbate existing inequalities or even create new ones? These are questions we really need to grapple with as this technology matures.
It's like we're standing at the edge of this new frontier, full of possibilities and uncertainties, and it's really up to us to navigate this uncharted territory responsibly and ethically.
Absolutely. And as we embark on this journey into the quantum realm, I think it's important to remember the words of Professor Anne Lewillier, the Nobel laureate in physics, who also spoke at the International Year of Quantum opening ceremony.
I remember her speech. It was incredibly inspiring.
She urged us to approach this field with a spirit of curiosity, a willingness to embrace the unknown, and a true commitment to using this knowledge for the betterment of humanity.
A powerful message to carry with us as we step into the quantum future.
Indeed. So as we conclude this deep dive into the world of quantum computing, I hope we've left you with a sense of wonder and a thirst for knowledge.
And maybe a few more questions than answers.
But that's the beauty of it, isn't it? The journey of discovery is just beginning.
Thank you for joining us on this exploration of the quantum realm. Until next time, keep exploring, keep questioning, and keep diving deep